Okay, now we're going to switch gears to a new note sheet called the Earth's Energy Budget. So please pull this out. Heat is a major factor of weather. The movement of heat causes our temperatures to change. It's responsible for our winds and rain. Nearly all of the energy in the Earth's atmosphere comes from the sun as electromagnetic waves. We classify these waves according to their wavelength. Solar energy travels to Earth three ways. The first is visible light, second is infrared radiation, and the third is ultraviolet radiation, but just a small amount. What I'd like you to do is take a second and star visible and infrared, because most of the energy that travels to the Earth comes to from these two sources. Now we're going to take a second and talk about each of these quickly. Visible light is a mixture of all the colors that you see in the rainbow. So that's our Roy G. Biv. The light spectrum is organized from shorter to longer. Red and orange are our longest, and blue and violet are our shortest waves. Infrared radiation is our second type we're going to talk about. Take a second to circle or underline the red in the word infrared. Infrared radiation has wavelengths that are longer than red light. It's invisible, and this is what we feel is heat. Now take a minute to underline or circle the violet and ultraviolet radiation. This too is invisible, wavelengths that are shorter than violet, and this is the type of light that causes sunburns, skin cancer, and eye damage like glaucoma. At the bottom of your paper, you'll see that you have a box. Take a minute and draw this illustration in your box. What type of radiation has waves that are shorter than visible light? If you said ultraviolet, you're absolutely correct. Which color of visible light has the longest wavelength? If you said red, you're absolutely correct. If you flip to the back of your paper, you'll see a blank picture that looks exactly like the picture on the PowerPoint slide. We're going to talk about how energy in the atmosphere, how the atmosphere uses the energy that the sun sends to it. This is called the energy budget, and just like your family has a budget where money comes in and we spend money on our daily needs, the Earth is the same way. So I'd like you to make sure by the end of this slide that your slide looks just like this. About 50% of the energy that comes from the sun is absorbed by the sun's surface. And you'll see that that's represented by the thick sun ray that comes down. Solar energy is mostly visible light and infrared radiation. It also has a small amount of ultraviolet radiation. This energy is the energy that heats the land and the water, both our infrared radiation and our visible light. Of that 100% of light that comes from the sun, after that 50% is absorbed, 25% gets reflected by the clouds and dust and gases in the air. For example, think about wearing a white t-shirt. That t-shirt reflects the light on a hot summer day, and you don't feel nearly as hot as you would wearing a black t-shirt. About 5% of that light is reflected by the surface back into the atmosphere. And the last 20% is absorbed by gases and particles in our atmosphere. This makes up 100% of the sun that comes in. And what happens to that 100%? It needs to be even to keep our energy from the sun in balance. If you take a look at this picture, it just goes into further detail about how our atmosphere absorbs this light. We know that the ozone layer absorbs most of the ultraviolet radiation. Some water vapor and carbon dioxide are absorbed by some of the infrared radiation. And then we also have the clouds and dust and other gases that absorb energy. Now remember that some sunlight is reflected back into space, just like a mirror. And it's like those clouds that would act like mirrors. At the Earth's surface, some of the sun's energy reaches the Earth's surface and gets reflected back into the atmosphere. About 1/2 is absorbed by land and water and gets changed to that heat that we feel and heats up our land and air. The last thing that we're going to do is go over a short greenhouse definition. And that is the process where heat is trapped in the atmosphere by gases that form a blanket around our Earth. Remember that the greenhouse effect is a natural process. It's used to keep Earth's atmosphere at a comfortable temperature. And over time, the amount of energy that gets absorbed by our atmosphere and the Earth's surface has to stay in balance with the amount of energy that's radiated back into outer space. That keeps our temperatures consistent.